So powers of monomials, okay? Unlike yesterday, this is a little bit different than yesterday. Notice what we have here. We have power to another power, right? Meaning this x to the second is raised to another power. It's the third power. And do you think that we're going to use the same rule as we studied yesterday? No. Now, what does this mean, first of all? What is the base of the exponent 3? Raise your hand. Yes. X squared is the base of exponent 3. So what does this mean? We need to multiply this base. Yes? X squared times x squared times x squared. And now, we could use the rule that we learned yesterday. Now we have multiplying all these powers, right? When you multiply these powers, what do we do with these exponents? Raise your hand. Who remembers? Yes, sir? Add them together. So we get x to the 6. You guys remember that? Now, anybody see a shortcut for something that has power to a power? Power to a power? How about Vlad? You can multiply them together. And so there is, it's called power to a power. When you have power to a power, meaning a to the m to the nth power, as you can see, it's raising that power to another power, right? Then we multiply the exponents. So write this down. And do you see why people get confused with adding and multiplying and so forth? Because we have both rules. And if you add when you're supposed to multiply, are you going to get the right answer? No, that's why we went over, right, the last lesson carefully. And here, as you can see, our base now is a to the m. You have a to the m multiplying n times. So it turns out that you're going to get a to the m times n. Okay, so write that down. Do you see how it is very different than the first fact we learned, or first rule of exponents? Right? What's the difference between our new rule versus the rule that we learned yesterday? Eric?
You have to multiply instead of adding x.
Right. But when do you multiply and when do you add? You see how people get confused?
When there's an exponent and parentheses.
Right. If it's power to a power, that's when you multiply. When you have the same base, right, of this exponent, then you add the exponent. You guys remember that? So please keep that in mind. I wrote them again so that you are familiar with these, okay? So try this example. I have 3 examples for you. Example 3, I put a star on that one. First, example 1 says m to the 3rd, the whole thing to the 4th power. Example 2, x squared to the 5th power. And example 3, negative b, quantity to the 4th. And the whole thing is now to the raised to the 5th power. So go ahead and try these, okay? You can tell me how to do example 1. 2 people? 3, 4, 5, 6, 7. How about Lucia? What do you think? M to the 12th power. What kind of work do you think I want to see? Which means just 3 times 4. I want to see something like this. Does that make sense? Okay, whoops. Let me try to hide it. Okay, so you're right. I want to see how you multiply 3 and 4 like that. Okay, I know that some of you could just do that in your head, but just to show me, show me that you understand that rule. Okay, what about example 2? What do we do for that one? How about random person? How about Viviana? X2 times 5, which is x to the? That's right. Any question there? Okay, what about example 3? How about Melissa? Okay, how many people got negative b to the 20th? Okay, is that fully simplified though? You're Algie, what do you think? Negative b in parentheses to the 20th? Okay, which is, yes, Melissa? It is positive b to the 20th. So you're right in putting negative b to the 20th, but I actually have it over here. So look at, there are two ways of thinking about this. First of all, you could just do, what about, don't you have to follow the order of operation, right? Order of operation says you have to deal with something inside the parentheses first. What's negative b to the fourth? If you multiply negative b, right, the base of this exponent 4 is whole negative b, right? There's the parentheses. So what happens if you multiply negative b even number of times? Does it become positive or negative? Positive. Therefore, I got positive b to the fourth. Now I use the rules, you know, that we just learned. 4 times 5 is 20. Or you could have thought of this. You could have done this way. You could just do 4 times 5, which is negative b to the 20th. But could I leave it negative b to the 20th as it is? No, that's not simplified fully, right? If you were to multiply negative b 20 times, right? If you multiply negative number even number of times, what does that become? Yes, positive. So you get positive b to the 20th. Does that make sense? So don't leave it this way. Whereas negative b to the 20th in parentheses, you should write it as positive b to the 20th. Austin, question.
If it would be switched around, like 4 and 5 would be switched around, it would be like just a different opposite.
If 4 and 5 were switched around, you still get
Positive.
positive because,
They
yeah, if the 5 was in here, yeah, you still multiply 4 at the end, and then it's going to be even number of times. Yes?
So like, I was gonna say, so like anything like negative multiply, I mean like to the power of an even like thing is like positive.
Okay, well, why don't you try this one first, guys? How about this? Negative b to the 4th to the 5th. Example 3b. Everybody tries. Let's see if this answers your question, okay? Try it, okay? Some of you, do you have the answer? Okay, just wait. I want all you to try. What do I get now? This looks very similar to the one that we just did, but I'm missing the parentheses around the negative b. So think about what this becomes. Okay, go ahead, just try it. Say it again, I didn't hear you. What?
Negative b to the 20th.
Negative b to the 20th. Is there any parentheses around anywhere? Around negative b? So you put negative b in parentheses to the 20th? Oh, b. Okay, you're right. So this just becomes, what is the class? Isn't it just negative b to the 20th without any parentheses? Right? Because why? Why is this different than example 3? Victor?
Because the negative isn't being multiplied by the power.
That's right. This negative, well, it is being multiplied, the negative. Think about, well, not by this exponent 4, but this exponent 5 it is, right? So you're going to multiply this negative 5 times. Negative 1, if you multiply negative 1 5 times, what do you get? Still negative, because you're multiplying negative 1 odd number of times, aren't you? So that's why this time you get negative b to the 20th. That's your answer. Does that make sense? Do you guys see the difference? Do you see how the parentheses, right, play a different role? It is important to understand what they mean, okay, when you have parentheses there. Good. How is this different than the other example? Yeah. There's a coefficient. All the other ones, we didn't have any coefficient. In other words, the base didn't contain any sort of number. Well, we had negative 1 and 1. So, what do you think this... First of all, what does it mean? 2y to the 4th in parentheses. Sarah?
Oh wait, I can read.
Oh, Kaylee?
It means that you distribute multiple 2 and y, or you can just do 2y 4 times.
2y times 2y. That's how I like to think of it, okay? So Benjamin, what do you think? This becomes then? And I even wrote down the invisible exponents, right? These all have exponents of 1. So using now the rules that we learned yesterday, first rule, what can we do? 2 to the what power, guys? 2 to the 4th, y to the 4th. You're right. And so, what is that, Gemma? Oh,
16y to 4.
that's right. Okay. How many forgot 16y to the 4th? Good. Now, some of you said something like, you could kind of, do you see sort of a pattern here? Okay. So some of you see a pattern, right? When I have like 2y to the 4, something like this is the same as, does anybody see a pattern? What if I have ab to the nth power? What would that be? ab, the whole thing to the nth power. Yeah. A to the n, b to the n. That's the third rule. Okay, we're gonna learn. If I have ab to the n, I said m, ab to the mth power, you get a to the m, b to the m. You kind of, am I using distributive property here? It's not really exactly a distributive property, right? Because you would need like a binomial or trinomial to distribute. But I know what you mean by so we are kind of giving this m to each of these base, right? Why? Why does this work this way? We sort of explained it up here. How many times are we multiplying AB? M times. Isn't that right? So if you multiply m times, of course you're gonna get AB times AB times AB, all this n of them. How many a's are you going to be multiplying? M times m of them. How many b's are you going to be multiplying b's? M of them. That's why you get AB to the m power equals what? A to the m, b to the m. So far we learned 3 rules, okay? Where you add the exponents when you have the same base, where you multiply the exponents when you what? Have power to a power, and here the third rule, when you have like more than one factors in your base, right? You give that exponent to each of those factors. Does that make sense? Okay, write that down. Knowing this, do I have to have only two variables? Could I have more than 2 variables in the parentheses? Does the rule still work? In other words, if I have ABC to the m power, what would that be? Yeah, Audrey? That's right, a to the m, b to the m, c to the m, of course all multiplying, right? So knowing this now, go ahead and try this example right here. Example 5 and 6. Let's see if you could apply that rule on these and get the right answer. Go ahead, try it. Raise your hand if you got negative for both of these expressions after you simplify. For both of them? Negative for both of them? Okay, how many people got negative for the first one only? How many people got negative for the second one only? Okay, that's how it should be. Why? And can somebody explain why? Why isn't the first expression, why does that turn to be positive? Yes, Austin? Yeah, it's going to be negative 4 times negative 4. You're multiplying negative number twice. So be careful when you do these. So yeah, but what about this exponent 2? What does this exponent see? Does it only see 4 or negative 4? It sees, yes? It sees a negative 4. Why? Because it's in the parentheses. It sees all that. Be careful. Does that make sense? So some of you forgot to do that as I looked at your work. Okay, so who could tell me what to write for this? For first expression? Yes, Alvin? 4x to what?
Negative 4 times negative 4.
Oh, you actually wrote them out. But let's use the rule that we just learned, the third rule. Knowing that rule, what could you do? Yeah, you could write it out. So that's actually a good point. If you ever get confused, you could write them all out. It may be helpful, okay? But since we're learning the rule, and it'll take us shorter time, Victor, what would you write?
Parentheses negative 4 squared.
Good.
Parentheses m squared.
Yes. Yeah, that's exactly. And as you can see, do you think that parentheses around negative 4 is important? If you don't put it there, then the whole thing becomes negative. That's not right. Okay. Oh, I'm sorry. Here you are. So therefore, you need the parentheses around negative 4, right? And of course, when you do this, Stefan, what does it become?
16 m squared n squared.
That's exactly right. Okay, you get positive 16 m squared n squared. Now, what about example 6? Who could tell me how to rewrite this now? Chemin, tell me what I write. Okay, you could do it that way. I actually wrote this negative as, what does that negative really mean? You could think of it as a coefficient, can't you, Audrey? What does it really mean? Negative 1. So could I write it as this way? Negative 1 to the third, m to the third, n to the third. But Chemin, you're right. I could actually do it. I wrote it in red. You could think of it as negative n to the third. It doesn't matter. Same thing, okay? But I just like to think of it as negative 1, the invisible 1, right? And when I do this, what do I get as the answer? Raise your hand now. Allie?
I got negative n in parentheses cubed and
Yeah, actually you don't need the parentheses. You could just write it as, negative 1 times m cubed n third, which is negative n to the third, n to the third. Does that make sense?